Okay, hello everyone. Welcome to the Physics 120 exam prep party. So we will try to go over the practice review exam, Unit 3 practice review exam, which is a quiz. I have, download all questions and I have put in the PDF file. So we will go over this problem together. So I start working on the problem just in case if any one of you have any question, you can, those who are online, okay, so you can just, raise your hand, okay, turn on your microphone and then ask your question. Those who are in person, okay, you can just raise your hand and ask your question, okay? So we start with the first question, okay? So the first question is telling a common source of wave motion is wave pattern, vibrating object, harmonic object, okay, region of the variable, high and low pressure, and none of these. Okay, so a source of wave is always vibration. So, and this is the right answer, not the wave pattern. Okay, so the wave is a kind of representing the source, which is have a vibrational motion. Good. So, the question number one, the right answer is vibrating object. Question number two, which of the following is not a transverse wave? So we know what is the difference between the transverse and longitudinal wave, okay? And transverse wave are wave which, the displacement and the vibration, okay, they are perpendicular. Good. So displacement of the wave, okay, and the vibration are perpendicular, but longitudinal, these two are in the same direction. They are parallel. So, and the light is one of the transverse wave. Sound is a longitudinal wave, is not the transverse wave. Okay, so I think the right answer is the sound. Radio wave is like a light. Okay, all electromagnetism wave, they are all transverse wave. So, but the only wave that in these options are is longitudinal wave is a sound. So again, we have two form of wave, transverse and longitudinal. If it's not transverse, okay, it's a longitudinal. Question number 3. In this question, it's asking how many vibration per second are associated with 101 mHz, or we call it megahertz. This represents a mega. Okay, mega is 1 million. Okay, mega is 1 million. And 1 million is, 1 with 6 0 in front. Okay, so we already know that the frequency is number of vibrations number of vibration over time. Good. So here, and the unit of the frequency is hertz. Okay, but here we have a 101 megahertz. 101 megahertz is means, first of all, we need to convert to the hertz. It's going to be 101. Instead of mega, we just put 60 in front. Okay, it's going to be hertz. So what does it mean? It means that 101 million vibration is happening in 1 second. So it is how many vibration? 101 vibration is happening in 1 second. Okay, this is called the frequency. So what is the right answer then? Okay, so the right answer is going to be 101 million vibration is happening in 1 second. Good. So question number 4. Number 4 is telling if the frequency of the certain wave is 10 hertz, its period, so the period is 1 over frequency. Or we can say frequency is 1 over period. Yes? Because we already have frequency, which is 10 hertz. If we want to calculate the period, we just write T equal 1 over 10 hertz. Yes? 1 over 10 hertz is going to be 0.1 second. Okay? So the right answer for question number 4, it is 0.1 second. Question number 5. Question number 5. An object that complete 20 vibration in 10 seconds has a frequency of, okay, perfect. We just explained what is the frequency means. The frequency is number of vibration and divided by time. Okay, how many vibration we have? 20 vibration divided by in how many seconds happening this 20 vibration in 10 second. Okay, so 20 divided by 10 is going to be 2 hertz. Okay, the unit of the hertz, hertz is it is 1 over second. Yes, 1 over second. So, and it's going to be 2 hertz. So what is the right answer then in this question? It is 2 hertz is the right answer. Good. So question number 6, wave interference occur in water wave, in light wave, in sound wave. So interference, it doesn't matter what kind of wave it is. Okay, so when we have more than one source of wave, more than one wave, okay, so interference happen if they see each other. Okay, so it doesn't matter, is a water wave, is a sound wave, mechanical wave, light wave. Okay, so the interference, okay, so it always happen in waves if they meet each other. So the right answer is all of the above choices are correct. And we know that when we have interference, we have two kind of interference: constructive interference and destructive interference. Constructive interference, the wave, kind of add each other, okay? But destructive interference, the waves are canceling each other. Good. So which we use this definition to explain the standing wave, if you remember. So question number 7. Question number 7 is telling that a Doppler effect occurs when a source of sound move away from you, toward you, either toward you or away from you. Okay, so whenever we have a source of wave, and it can be sound source or light source, it doesn't matter. It's the source is moving toward you or moving away from you. You will have a blue shift or red shift. Red shift is moving away from you, and blue shift is moving toward you. So the right option, the correct option here is either toward you or away from you. Okay, so when the sound source is moving toward you, the frequency increase, but the wavelengths decrease. Okay, so that's why we have a blue shift. Okay, when the sound source is moving away from you, the frequency decrease, but the wavelengths increase. We have a red shift. Good. Hmm? Yes, whenever the sound source, okay, is moving, or sound source or light source, it doesn't matter, is moving away from you, the frequency that you hear or you listen or you see is decreasing. Okay, when it's moving away from you. But as we know, the frequency and wavelength are inversely related to each other. So if the frequency decrease, the wavelengths increase. That's why we call it redshift. So number 8, an observer on the ground hear a sonic boom which is created by an airplane flying at a speed. Okay, so we know that this happened when the speed is greater than the speed of sound. Yes, the sonic boom will always happen when the speed of the sound source, okay, the source which is creating a sound, is greater than the velocity of the sound. So, and the right answer is greater. Okay. So, question number 9. The source of sonic boom. So, the source of sonic boom may or may not be an emitter of the sound. Yes? Okay. So, the right answer is the first one.
What was 8? It was greater than the speed of sound, yeah?
Yes, yes. The
Okay,
effect is
okay.
greater than the speed of sound.
I wasn't paying attention when we went over it, and I was like, oh, I hope I clicked on the right answer.
No, no, no. It is a greater than
I did in fact click on the right answer. Okay, cool.
Okay, good. Perfect. So, question number 9, we just answered question number 9. And question number 10, it is, if waves are going by at the same speed, the wave with the greatest period of oscillation is the wave that has the greatest wavelength. Yes? So, the same speed, if you want to have the same speed, okay, so with the greatest period, it means that it should have the less frequency, yes, because the frequency is 1 over t. If the t is great, okay, the frequency is less. Okay, if we want to have the same speed, if the frequency decrease, the wavelength should be increasing, yes? Okay, the velocity is frequency multiplied by wavelength. If we want to have the same frequency, yes, sorry, same velocity, if the frequency decrease, yes, if this is decreasing, the lambda should be increasing. That's why the right answer is the wave that has the greatest wavelength, okay, will cause this wave have the same velocity. Okay, question number 11. Okay, a floating leaf oscillates up and down two complete cycle in 1 second. Okay, so this is the definition of the frequency, yes? Good. Complete cycle in 1 second. So it means that the number of vibration over time, 2 vibration over 1 second, yes? 2 over 1 is going to be 2 hertz. So this means this is a 2 hertz. This object is creating frequency with 2 hertz. So, and the question is given the wavelengths. The wavelength is 10 meter. So what is the wave speed? The wave speed is frequency multiplied by lambda. What is the frequency? Again, 2 hertz. Okay, multiplied by 10 meter. Okay, as we know, the hertz is 1 second. Yes, 1 over second. So 2 hertz times 10 is going to be 20 meter per second. Okay. So what is the right answer? It is 20 meter per second. So question number 12. The frequency of the second hand on the clock. Okay, second hand, it means that the one that is showing the second. Yes. Good. So how many seconds it will take to complete one cycle? 60 seconds. Okay, 60 seconds takes to complete one cycle. So we know that the frequency of number of vibration, okay, one cycle over the time period. Okay, one cycle over 60 seconds. Okay, so what is the right answer here? So it means that the frequency is 1 over 60 hertz. Good. So number 13. For number 13. So question number 13. For light, a red shift indicate that the light source is what happened? Perfect. Is moving away from you. So we just explained that, yes? Number 14, if you double the frequency of a vibrating object, okay, so what happened to period? As again, T is 1 over frequency. Period and the frequency are inversely related to each other. Okay, so if you double the frequency, definitely this period will become less, okay, and it's become half. So the right answer is half. Number 15. So number 15 is exactly like the question that we solved before. Okay, so again, a floating object. Okay, so oscillate up and down to complete cycle in 1 second. So again, what this means, it means that it is 2 hertz. Yes, number of cycle, number of vibration over time. 2 vibration over 1 second. So it's going to be 2 hertz. So frequency is 2 hertz. And a water wavelength is 5 meter pass by. Yes? So the wavelength is 5 meter. So what does it mean? So what is the speed of wave? The speed of wave is frequency multiplied by lambda 2 times 2 hertz time 5 meter. Okay, the velocity will be 10 meter per second. Yes? So the right answer is 10 meter per second. Question number 16.
I'm sorry, could you go back up to 14 for a second?
14. Yes. This is 14. If you double the frequency of a vibrating object, okay, its period, okay, the period and the frequency are inversely related to each other, okay? If you double the frequency, the period will be half.
Left?
Good.
Okay.
Do you have any question about number 15?
No, I'm good with that one. Thank you.
Yeah. Question number 16. So in this question, it's telling that a skipper on a boat noticed wave crest passing the anchor chain every 5 seconds. So, you see, let's say this is a wave, yes? The water wave. Well, good. And, this person is seeing every one of these crests, yes? How many seconds? Every 5 seconds. Let's say he was here, okay, and then the wave 5 seconds later, okay, is here, okay? So, good. So, what these represent? This is the definition of the period, okay? So, the T is 5 seconds. When we have the period, we can calculate the frequency. The frequency will be 1 over 5 second. 1 over 5 is 0.2 hertz, yes? So we just calculate the frequency of the water wave. Okay? Good? So, and what is the next part? Okay, see, the first sentence give me a lot of information, okay? I just read the first sentence, okay, and this sentence gave me a lot of information. So 5 second, okay, and which the 5 second is the period, okay. The frequency is going to be 1 over 5 second, okay, which is going to be 0.2 hertz. So what is the second part? The second part, let me just use different color. The skipper estimate the distance between these two crests. Okay, the real distance between these two, yes, it is 15 meter. We call the distance between two consecutive crests wavelengths. Okay, so the wavelength is going to be 15 meter. Okay, Okay, what the question is asking to calculate? Speed of water. So we know the wavelengths of the water. We know the frequency of the water. Okay, so and if we want to calculate the velocity, we just multiply these two terms together. Frequency is 0.2 hertz multiplied by 15 meter. Good. So velocity will be 3 meter per second. What is the right answer? 3 meter per second is the right answer. Or you would be able to just use the formula that you learned from first unit. Okay, what is the velocity? The velocity, let me just use different color. The velocity is x over time, yes? What is the distance between two waves? 15 meter. How many times second later? 5 seconds. 15 divided by 5 is going to be 3 meter per second. Okay, any question? Good. Let's move on to the next problem. Number 17, yes. A jet traveling at 1500 kilometer per hour passes between observer A and B in a short time. A sonic boom will be heard by both, yes? Okay. So it will be heard by both, but not the pilot. But because pilot is a part of the sound source, yes? Okay. The source, the sound is created by the airplane, okay? The sound source and the pilot, they are together. They are moving with the same velocity, okay? And the right answer for this one is gonna be observer A and observer B, but not the pilot, yes? So question number 18. So the question number 18 is asking, as a source of continuous sound approaches you at a constant speed, you will be aware of a apparent increasing in, definitely the frequency is increasing, yes? The loudness, okay, so because it's getting toward you, good. When it's getting toward you, the cross section of the wave, which is transferring the energy, will decrease. The power is intensity, okay? So the power is intensity. In the power, when we have a small cross section, so we will have a bigger intensity. So frequency and the loudness are the right answer for this question. So number 19. If at a concert you run toward the orchestra, the frequency of the sound you hear will be, what is the Doppler effect? What the Doppler effect says, okay, when the sound source is moving toward you, the frequency increase, yes? The frequency will increase. Number 20. A sound source of high frequency emits high, not amplitude, not speed. Okay, yes, pitch. Okay, pitch. Other word we can use for the frequency is the pitch. Yeah, the pitch is the right answer. Okay, so these two are right. So again, this question you should already know. The approximate range of human hearing in hertz is between 20 to 20 hertz. Okay, so we cannot hear a sound with less than 20 hertz, and we cannot hear the sound less than bigger than 20,000 hertz. Okay, so and what is the right answer? Okay, the right answer is the first option. Okay, number 22. Compression and rarefaction are characteristic of We just said, okay, longitudinal wave, okay, we have a compression and rarefaction. Okay, in the compression, the constructive interference happening, yes? Compression, the constructive interference happening. In the rarefaction, okay, the destructive interference happening. So, and we define the longitudinal wave with the compression and the rarefaction. So the right answer will be longitudinal wave. Okay, so number 23. Sound waves cannot travel in. So one of the waves that need medium to travel is sound wave. So sound wave, let's say we are creating a sound, okay? The sound will travel and you to your eardrum, okay, and you can hear what I am telling. So, and what is transferring this wave is the air. Air is the medium that can transfer the sound wave. So, but if there is no air, so it means that there is no medium to transfer the wave. So the right answer is vacuum. So, but the light can transfer even in the vacuum. Okay, the light doesn't need this. The light wave doesn't need medium to be transferred. So 24. Good. A wave having, so 24. A wave having frequency of 1000 hertz. Okay, vibrate. Okay, again, 1000 cycle per second. Yes. Okay, we just explained this couple of times. Frequency is the number of vibration over time. Number 25. So what is the 25? When the speed of sound near the ground is greater than it is at higher altitude, the sound tend to be bent. Yes? Okay. But when it's bent, it's bends upward or downward. No, the speed of sound in near the ground is greater than higher altitude. Okay, so if it's bent upward. Okay. So 26. So in perceiving its environment, a dolphin makes use of the Doppler effect, echoes, ultrasound. Okay, so or all of the above choices are correct. Okay, so all of the above choices are correct because the dolphins use the Doppler effect, echoes, and ultrasound. So this option is correct. 27. The wavelengths of sound that carry farther in the air are relatively, so the wavelengths that carry farther, so it means that if the wavelength is bigger, good, what is in the air are relatively, I just said, okay, long, okay, so if farther, okay, it means that the wavelength is long, okay, because the wavelength is long, that's why they can travel farther. So number 28, the natural frequency of the object, it's depend on shape, elasticity, and size. So the size is important, shape is important, and elasticity is important. These three related to the natural frequency of the object. So 29. So what is the 29? 29 is telling that some singers have been said to shatter a crystal chandelier shatter with their voice. This is a demonstration of the resonance. Yes. So this is the demonstration of the resonance. What is the resonance? Resonance, because we know that each object has its own natural frequency. If you create a wave which its frequency become equal to the natural frequency of the any object, at this point the resonance happen. Good? So this is the definition of the resonance. Okay, so if you are creating a wave with a frequency that this frequency is close to the natural frequency of the object, so we'll have a resonance. Good? Number 30, phenomenon of bits resolve from sound. How the bit is created? By the interference, yes? Good? So constructive and destructive interference. Not the reflection, not the rarefaction, okay, not the refraction. So 31, in the case of radio, which has the higher frequency? Carrier wave, sound wave, neither both. So the carrier wave does have a higher frequency, okay? So 32, a 340 hertz sound wave travel at 340 meter per second. So we have the frequency, it is 340 hertz. We have a velocity, it is 340 meter per second. So we already know that the velocity is frequency multiplied by lambda, yes? If we want, we can rewrite this equation and write lambda equal velocity over frequency. Good? So what is the velocity here? 340 meter per second. What is the frequency? 340 hertz. Okay, 340 divided by 340 is going to be 1 meter. And it makes sense. Okay, this is a meter per second. This is a hertz. Hertz is 1 over second. Yes, 1 over second, 1 over second. Cancel each other. What is left is going to be meter. So the right answer is 1 meter. Okay. So in which one of these media doesn't sound travel the fast? Ice. Yes? Good.
But what do you look for?
Does sound travel fast? Okay, does sound travel fast? Okay, it means that the more condensed material, okay, the better the sound wave can travel. Okay, so 34, the bit frequency produced when a 240 hertz tuning fork and 246 hertz tuning fork are sounded together. So it means that the frequency by two sound source. How the beat is created, okay, by if you subtract the frequency, yes, the beat, you can calculate the beats, yes, the beat frequency, which is F2 minus F1. Good, what is the F2? 246 minus 240 hertz. What is the answer? 6 hertz. So 35, it's telling the general rule for estimating the distance in kilometer between an observer and a lightning bolt is to count the number of seconds between seeing the lightning and hearing it. So how many second rule? It is a 3-second rule, and you can just do this, okay, when there is a lightning. Okay, so you hear the, sorry, you see the lightning first, okay, and then you hear the sound. Why? Because the velocity of the light is 300 million per second, but the velocity of this sound, okay, is 340-50 meter per second, okay? Good. So 3 second is the rule that we just used to find the different time when you hear and you see the light. hear the sound and see the light. Okay. So 36, the pitch of musical sound is I said, okay, the pitch is related to the frequency. Okay. So pitch and frequency are related. Okay. They are same thing, representing the same thing. So the loudness of a musical sound is a measure of the sound wave. The loudness is what? The amplitude. Yes? The amplitude. The loudness, okay, is related to the amplitude, not the speed, not the wavelengths, not the frequency. Okay, because the frequency, speed. Speed is kind of frequency multiplied by wavelengths. Okay. So the amplitude is the kind of representing the loudness. The bigger amplitude, okay, the bigger loudness. Okay, 38. These are the good questions. Okay, these are the graph questions. So I will explain a little more about this problem. So in the first question, we have a wave, but the graph of wave, but it shows the displacement over position. Yeah, sorry, displacement over time. Yes, because h is the time, and then g representing the displacement in centimeter. The graph above has a dimension of g 4, 4. Okay, so 4 from here to here is 4, and this is a negative 4. Good. So how many units we have? Okay, so this is a 1 unit. Yes. 2, 3, 4. Good. So from here to here is 4. So it means that each of these unit is 1 centimeter. Good. Okay. So what is the h? H here is 190 second. So again, h here is 190 second. So again, we just try to just count these units. Yes. How many units? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So 190 divided by 10 is 19. Yes. Okay. So what does it mean? It means that each one of these represent 19 seconds. Good? Make sense? So again, G to G is 4, negative 4. We just count this S squared, yes? 1, 2, 3, 4. Okay, 4 divided by 4 is going to be 1 centimeter. Each one of these representing 1 centimeter. Okay, but here we have 10 square, yes. Okay, from here to here is 19, 190. 190 divided by 10 is going to be each one of these to present 19 seconds. Okay, this is how to just read the graph. This is the important part. But the question is, calculate the period of this wave. So the period is when same, we have the distance between two consecutive crests or two consecutive trough or two same consecutive point on the wave. Okay, I can say here and here two consecutive crests. Yes, crest, crest. I can say from here to here is two consecutive trough. Yes, T, T. Or I can say two same point. It can be anywhere. So this, yes, this point, and then this point, yes. They are representing the same, the same consecutive point. Okay. So the time from here to here is going to be period. Okay. The time from here to here is going to be period. The time from here to here is going to be period. Because, we can use any of those. It doesn't matter. Good? So I'll use the crest. Okay, so how many unit I have? Okay, let me just use different color. How many unit? 1, 2, 3, 4, 5. Yes. So T is gonna be 5 times. What was the each one of these? 19. Yes. 5 times 19 will be 5 times 19 will be 5 95. Yes. Good. 95 second. Okay, the right answer is a blank. Okay, you need to put your answer 95. It's not the multiple choice. Good.
Have to put 95 into 2 decimals.
No, 95 second. Why two decimal places?
If it goes into 2 decimal places.
Okay, so do you need two decimal places? Okay, you can write 95 or 95.00. This is going to be two decimal places, yes? But and both of these will be correct. Okay. It is asking whenever you have a decimal number. Okay, so you can, when its decimal numbers are 00, okay, you would be fine. Good. So first of all, you need to know how to analyze the graph. Okay, so we have a wave, and the wave representing the displacement over time. Yes. So the time will give you the period. And if you have a period, you can calculate the frequency. Probably next question is asking to calculate the frequency by having a graph of displacement over time. Okay, let's see what is the next question. So do you have any question? No? Jacob, are you good?
I am good, thank you.
Okay, perfect. So this one is kind of representing wave, yes? Displacement over position. So whenever we have position, we can calculate the wavelengths. Whenever we have a displacement over time, we can calculate the period. Okay, so this will give us the position. So the graph above have the dimension of g4, negative g, negative 4. Okay, so again here, negative 4, and then here is positive 4. Yes. So I need to see how many units we have. 1, 2, 3, 4, 5, 6. Yes. So 4 divided by 6 is going to be 4 divided. Just say 4 divided by 6 is going to be 2/3. Yes. Each one of these units. Okay. Each one of these unit is how much? 2/3 centimeter. Okay. So, and what is the h here? H is representing the position, is 100 meter. Okay, great. So again, we start counting the number of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, if h is 100, if we divide 100 by 10, it's going to be 10 meter. Each one of these represent 10 meter. Good. So again, you remember when we have a displacement over time, two consecutive points will give you the period. Here, when we have a displacement over position, two consecutive point, okay, in the wave will give you the wavelength. Yes? Okay, so I can say the distance between two cross, okay, it is the two consecutive. Okay, I can say this is a lambda. So let me just change the color. So, and then I can just select these 2 points. Okay. This point, yes. And then this point. Okay. Good. Because, you know, when it, after this point is going up, after this point is going up. Yes. So this is going to be the lambda. Okay. So, and I can use the other color. Let me just use this one. Again, now this is a trough. This is a trough. Yes. The distance between two trough is going to be wave length. So you can use any of those, okay, to calculate the wavelength. So okay, I use the yellow one, okay? So the distance between this point to this point, how many points we have? You know, 1, 2, 3, 4, 5. Yes? 1, 2, 3, 4, 5. Okay? So, and each one is 10 meter. Yes? 5 times 10 meter is going to be 50 meter. So I calculate the wavelength here. It was asking to calculate the wavelength. Yes? So we just calculated the wavelength. So it's going to be 50 meter. Good? Any question? Okay. One more wave. So we need to see what is the G and H. Okay, G is 24, yes. We just count 1, 2, 3, 4, 5, 6, yes. 24 divided by 6 is going to be 4 centimeter. So each one of these is representing 4 centimeter. Okay, what is the H here? Again, this is a displacement over time. We can calculate the period and frequency. So what is the H? H is 120. Good. H is 120. Again, just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 120 divided by 10 is going to be 12 seconds. Each one of these represent 12 seconds. What is the question is asking to calculate? Okay, let me just change the color. The question is asking to give your answer in decimal places. Okay. Oh, what? Calculate the amplitude. Okay, we didn't even need to just do the x-axis. Okay, the amplitude is the distance from midpoint to the cross, or this is called the midpoint. Okay, so this is gonna be amplitude, or the distance from the midpoint to the trough. Yes, this is gonna be amplitude. Good. So how many unit it is? It is 1, 2, 3. Yes. Okay. So it's from here to here. 3 times 4. So 3 times 4 is going to be 12 centimeter. Okay, so you can just write 12.002 centimeter. Okay, so this is going to be amplitude. Okay, so let's see. We have one more. Okay, so what is the GMY? Again, this is a displacement over time again. So what is the displacement? G is 20, 20. Okay, good. So let me just count. Okay, from here is 20. 1, 2, 3, 4. Good. 20 divided by 4 will be 5 centimeter. So each one of these representing 5 centimeter. The y-axis. Okay, so what was the h? H is 20 second. Okay, good. 20 seconds. So again, I think it's 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. 20 divided by 10 is going to be 2 seconds. So each one of these represent 2 seconds. Good. So what is asking us to calculate? Give your calculate the frequency. Okay. So again, we need to find the period first. Yes. I just use these 2 points. Okay. So again, you can use the distance between two trough or 2 consecutive points. Okay. I use this. From here to here is how many seconds? We have 1, 2, 3, 4, 5. 5 times 2. Yes. Because each one is 2 seconds. How many 2 seconds we have? How many of these we have? 1, 2, 3, 4, 5. Yes. From here to here. Good. Okay. The distance between 2 crests. How many of these we have? 1, 2, 3, 4, 5. Okay. So each one is 2 seconds. 5 times 2 seconds is going to be 10 seconds. So the T, let me just write with a different color. The T is 10 seconds, the period. So what is the frequency? Frequency is 1 over 10 seconds. 1 over 10 seconds is going to be 0.1 hertz, yes? So the frequency is two decimal places. What you can write? Okay, you can write frequency is 0.10 hertz. Good? 0.1 or 0.10? Okay, the last one. Okay, the last one is displacement over again time. Good. So what is the G? G is 8. What is the H? 8 is 80. So how many units we have? 1, 2, 3, 4. Okay. 8 divided by 4 is going to be 2 centimeter. So from here to here is 2 centimeter. Good. And H is 80. So I think we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 80. So 80 divided by 8 is, sorry, 80 divided by 10 is 8 seconds. Okay. So each one of these represent 8 seconds. Good. So, and okay, if we just analyze the graph, okay, let's see what we are supposed to calculate. You know, it's telling that if the wavelength is the 170, so if we have the wavelength is 170 meter, okay, we cannot find the wavelength from this graph, yes, because this graph is displacement over time. It just give us the period or frequency. Okay, we can calculate the period and then do the calculation to calculate the frequency. So we have the wavelength is 170, but it's calculating. Okay, calculate the speed. What is the speed formula? Frequency multiplied by lambda. We already have lambda. Yes, it is 170 meter. Okay, the question is given the lambda. Good, the wavelength. So we need to find the frequency. Okay, if we want to find the frequency, we are supposed to use these graph, yes? So the distance between two crests, yes? In the displacement over time. So this is a crest, this is a crest. So this will give us period, yes? 1, okay, from here to here is 1, 2, 3, 4, 5, yes? So it means that 5 times how many? 8. Good. 5 times 8 is 40 seconds. So you can calculate the frequency. The frequency is going to be 1 over t. It's going to be 1 over 40. Good. So, okay, we have the frequency is 1 over 40 hertz. Okay, so, and then we have the lambda. Okay, frequency is 1 over 40 hertz. Good. So what is the velocity? 1 over 40 hertz multiplied by 170 meter. Good? It's going to be 170 over 40. It's going to be 17 over 4. So we need to round it to do decimal places. Yes? So 17 divided by 4 is going to be 4.20. 4.25 meter per second. So the velocity will be 4.25 meter per second. Okay, so this is the velocity of wave in meter per second. Good. So let me just check one more time that we see we are in the right. Okay, h is 80. So 80 divided by 10 is going to be 8 seconds. That's right. So G is 8. Okay, so if it is 8, 1, 2, 3, 4, the 8 divided by 4 is going to be 2 centimeter. Yes. So we just need to find the frequency. Okay, the frequency, we need to find the period first. Okay, the distance between two consecutive points. So it's going to give us the period time. So 1, 2, 3, 4, 5. Okay, 5 times each one representing 8 seconds. Okay, 5 times 8 is going to be 40 seconds. We have the t. We can calculate the frequency. Frequency is 1 over t, 1 over 40 hertz. Okay, we have 1 over 40. and we have a wavelength, okay? So wavelength is already given. So we can multiply these two, okay? So we can calculate the velocity. Okay. You have a question? So we analyze the graph to see what the graph exactly means. Okay, so we may not, you said, as you saw, okay, we don't need the amplitude, we don't need the y-axis. Okay, but I always analyze to make sure that I know what exactly means. Okay, so okay, so we are done with this one. Okay, so I'll give you 5-minute break. Okay, and then we will start the next file. Okay, so and this is a graph file. Okay, that file that was related to the standing wave. Okay, good. So right now we will be working on the second part of the practice review, which is graph practice, and mostly we will be talking about the standing wave. Here is telling that we have a standing wave here. It is being vibrated at this frequency. What does it mean? So you see the graph, okay, you see a two loop in the graph, yes? Okay, two loop, it means that it is a second harmonic. A standing wave, it's in second harmonic, yes?
When there's three,
When there is three, okay, third harmonic. When it's one, okay, it's the first harmonic, okay, or we call it fundamental harmonic, okay? So the number of loops, yes?
what is it?
When there is a one loop, yes. When there is a one loop, okay, we will have, okay, so when, so this frequency, then this frequency is the frequency of the second harmonic, yes? Which is 80 hertz. So I may ask you, okay, what is the frequency of the first harmonic? The frequency of the first harmonic, if we have the first harmonic, if you double the first harmonic frequency, you will get second harmonic. So it means that the first harmonic frequency was 40 hertz. Okay, how we got this? Okay, we divided 80 by 2. Good? 80 by 2, okay, so 80 divided by 2 is going to be the fundamental frequency. Okay, but what is the harmonic that is vibrating? Number A is going to be second harmonic, yes? What is the B? What is the wavelength of that harmonic? It means that what is the wavelength of the second harmonic, yes? So, and I look at the graph, okay, here. So you see here we have two loops, okay? So each one of loop represent a 1/2 a lambda, yes? So from here to here is half a lambda, and from here to here is half a lambda, yes? So let's say we have a string, and the string has, what is the length of the string? From here to here is the length of the string, yes? L is 30 meter. Good. So, and then we are supposed to calculate this lambda. We say that 1 lambda, half a lambda plus half a lambda become equal to the length of the string. Yes. Good. So, and half a lambda plus half a lambda is going to be just 1 lambda. 1 lambda is equal to L. So this will be the lambda of the second harmonic. Yes. Good. Okay, because we have two loops. And what is the L? L is 30. So the 30 meter. So we kind of calculated the wavelength of the second harmonic. Good. So CB is going to be the wavelength of the second harmonic. Okay, which is going to be 30. What is it? Is in centimeter, yes? No, it is in meter. 30 meter. Okay, C. What is the C? What is the speed of wave? what is the speed of wave? Okay, if we are supposed to calculate the speed of wave, okay, we can just say wave speed is frequency of the second multiplied by the wavelength of the second. Yes, you cannot multiply the frequency of the first harmonic to the wavelength of the fifth harmonic, for instance. Okay, you need to just use the both at the same harmonic. Yes. So what is the velocity then? Okay, we already have the frequency of the second harmonic. It is 80 hertz. We have the wavelength of the second harmonic. It is 30 meter. Yes. When you multiply these two, 80 times 30 is going to be 2400 meter per second. Okay, so the velocity is going to be 2400 meter per second. So again, when you are calculating the frequency, when you are calculating the velocity, the frequency and the wavelength should be in the same harmonic. Okay, if you have the frequency of the first harmonic and you are supposed to calculate the velocity, you need to find the wavelength of the first harmonic. Yes, frequency of the first harmonic multiplied by the wavelength of the first harmonic give you the velocity. And if we just do this, okay, we will get the same velocity. So it doesn't matter in what harmonic you are in the standing wave. You should always get the same velocity. Same velocity for the same first harmonic, second harmonic, third harmonic, and so on. Okay. I think we already did D, yes? Okay, D is telling what is the fundamental or the first harmonic. We just said that if the second harmonic is 80, you divide it by 2, you will get the first harmonic. Okay, so the first harmonic is, let's say if you had this, this graph had the 3 loops, yes? So it means that it was third harmonic. Okay, so what you were supposed to do to calculate the first harmonic, you should divide it by 3. Okay, to be able to get the first harmonic. Because we are in the second loop, okay, so we can divide it by 2 and to get the first harmonic or the fundamental harmonic, which is the 80 divided by 2 is going to be 40 hertz. Yes?
So
Hmm?
can you repeat?
So we have the frequency of the second harmonic. Yes? If we want to calculate the fundamental frequency of the frequency of the first harmonic, we just divide the second harmonic frequency by 2. Okay? Why 2? Because there are 2 loops. Yes? If there was 3 loops, okay, so we would divide it by 3. Okay?
So you want to divide by 3 the second harmonic.
Divided by 2.
Yes, for the second.
Yeah, yes. No. For again. So you have the frequency of the second harmonic. The frequency of the second harmonic is 80 hertz. Yes, see? If you want to find the first harmonic frequency, you need to divide by 40. That's it.
By 3. I mean
3. Okay, you just multiply the first one by 3. What is the frequency? 40. Yes, 40 times 3 is going to be 120 if you are calculating the third harmonic frequency. Yes, okay. So E is telling, let me just change the call. E is saying, what is the wavelength of the first harmonic? Okay, so the first harmonic, okay, it will be one loop. I will graph the first harmonic, okay? So this is going to be first harmonic, yes? Good? Okay. So in the first harmonic, okay, if I want to graph a little better, okay, I can graph it here. So if there is a wavelength, okay, so this is going to be first harmonic, yes? So first harmonic, so from here to here is how much? 30 meter, good. So we know that each one of these loop representing half a lambda, yes? Half a lambda. Okay, so half a lambda is equal to the 30, yes? 30. So how we can find the lambda? Here, just solve for lambda. How? Multiply both sides by 2, yes? Multiply both sides by 2. 2 and 2 cancel each other. So the wavelength of the first harmonic, yes, is going to be 60 meter. Good? So the answer for E, I'll just go 60 meter. Good? Let's say if we had a fifth harmonic, okay? It is not part of your example, okay? So I'll just do just in case, okay? Let's say if we are supposed to calculate let's say calculate the wavelength of, yes, fifth harmonic, yes? It is not part of the question, but I just showing you how to calculate. Wavelength and frequency, okay? Let's say frequency, both. Good? So fifth harmonic, what does it mean? Okay, I'll just do again with this. Okay, from here to, oh, from here, yes, to here. Okay, so how many loop we should have? 5 loop. Okay, so let's say 1, 2, 3, 4, 5. Yes. So it's gonna be 1, 2, 3, 4, 5. Good. So this is gonna be fifth harmonic. Why? 1, 2, 3, 4, 5. Okay, from here to here is how many? Is 30. 30 meter. Good.
Doesn't matter if any.
Yeah, because we are using the same string. Okay, you are using the same string with the same lengths, okay, and creating a different harmonic. 1 loop, 2 loop, 3 loop. So, and I back to calculation. Okay, so, and I said that each one of this is half a lambda, yes? Half a lambda, half a lambda, half a lambda, and half a lambda. How many half a lambda I have? I have 5 half a lambda is equal to 30. So I can find the wavelengths of the fifth harmonic. Good. So how I can calculate this? Okay. The times by 2, yes. 2 and 2 cancel each other. It's going to be 5 lambda equals 60, yes. And then divided by 5, divided by 5. So what is the lambda here? The lambda here is going to be the fifth, yes. It's going to be 12. 60 divided by 5 is going to be 12 meter. Okay, this is a lambda. How I can calculate the frequency? So how I can calculate the frequency of the fifth harmonic? Yes? You multiply by 5, yes? You already have the first harmonic, okay? So 5 times of the first harmonic, yes, is going to be the frequency of the fifth harmonic. Good? Again, you have the first harmonic, okay? When you multiply it by 5, okay, you will get the frequency of the fifth harmonic. If you multiply by 6, you can get the frequency of the sixth harmonic. Good? So 5 times, what is the frequency of the first harmonic that we calculated? No, it was 40. Okay, so it was 40. So 5 times 40, 200 hertz, yes? So frequency of the fifth harmonic is going to be 200 hertz. Let's say if I asked you to calculate the velocity, you remember I said that the velocity never changed? Let's see what happened here. So we have velocity, the frequency of the fifth harmonic multiplied by lambda of fifth harmonic, yes? What is the frequency? 200 hertz multiplied by 12 meter. So 200 times 12 is going to be 2400 meter per second. Yep. So again, you remember we just calculated the velocity of the second harmonic. It was 2400 meter per second here. The velocity of the fifth harmonic is again is going to be 2400 meter per second. It doesn't matter in what harmonic we have. Okay. So this was the extra, okay, question which I solved. This wasn't part of this example. I just wanted to show you that if we have a, fifth harmonic, okay, how it's going to look like, how we can calculate the wavelengths, how we can calculate the frequency. Good? Okay. Any question? So let me just go to part. Okay, what is the last one? The last one is telling that what is the amplitude. Okay, so what is the amplitude? The amplitude is the distance from the midpoint to the crest, yes? Or the distance, this is the amplitude, or the distance from the midpoint to trough, yes? A. So, okay, how many centimeter is 2, 4, 6, 8, 10? Yes, it's going to be 10 centimeters. So A is going to be 10 centimeter. Okay. Okay, so we are done with this the first problem. Okay, so if you don't have any question, we can just move on to the next problem. So, and here in this next problem is telling that there are two diagrams below, one with respect to time and one respect to distance. Okay, so this is a one respect to the time. Okay, so here it will help us to calculate the period and frequency, but the other one is respect with the distance, which help us to calculate the wavelengths. Yes. So what the first question? Give the value of the period. Okay, which one we are supposed to use to find the period? The first one. Okay, so again, the distance between two consecutive points. Yes. So I can say the distance between two cross, or the distance between these 2 points. Yes. Good. Or the distance between two. Okay, there was no trough. Okay, we cannot use this. Okay, so this one will give us. I use this one. Okay. T. What is the T? From here to here is 30 seconds. So 30 seconds. Great. So the period will be 30 seconds. Good. So the B is telling what is the value of the wavelengths. Okay, so wavelengths, can I use the first graph? No. Okay. So because it's displacement over time. Okay, we are supposed to use the second graph because it's displacement over the distance. Okay, so what is the wavelength definition? The distance, because we have two crests here, okay? We can just use these two crests, yes? So this is the first crest. This is the second crest. Okay, the distance between two consecutive crests, okay? So will give us the lambda. What is the lambda here? 30 meter, okay? Good. So this is gonna be lambda. Lambda is gonna be 30 meter. So, okay, find the value of amplitude. For finding the amplitude, it doesn't matter which one you are looking. Okay, both will give you the same amplitude, yes? Okay, again, the distance from the midpoint to the cross, okay, or trough, okay, it is 10 centimeter, okay, so 10 centimeter. So here, the distance from the middle point, yes, to the crest It is again 10 centimeter, yes? 10 centimeter. So amplitude is gonna be 10 centimeter. Okay, find the frequency. How we can find the frequency? We already have the period, yes? So frequency is 1 over t. It's gonna be 1 over 30 second. You can just calculate this by using your graph, calculator. Okay, but it's not necessary. So find the velocity. The velocity. The velocity is gonna be frequency multiplied by wavelengths, yes? What is the frequency? 1 over 30. Okay, hertz. Okay, sorry, this was no hertz. 1 over 30 hertz. 1 over 30 hertz multiplied by what is the wavelength? 30 meter, yes? Okay, 1 over 30 times 30, 30 and 30 cancel each other. What is left? 1 meter per second. So the velocity is 1 meter per second. Okay. Okay. Draw a wave on the first diagram that completely cancel the wave. Okay. So it means that, let me just erase this. If I want to draw a graph that completely cancel, so it means that if we have a crest, yes, we need to draw a trough. When we have a trough, we need to have a crest. Okay, so I'll do this. When I have a crest, okay, so I will have a trough. When I have a trough, okay, I will have crest. Okay, so the same thing, you do the same thing with other point as well. Okay, so I'll do this. Okay, sorry, I cannot draw a little. Good. So these two, they completely cancel each other. Okay, so this is part F. Draw a wave on the second diagram. On the second diagram, that's completely constructive. Okay, so it means that we are supposed to graph the same graph, yes? So let me just use different color. So if I draw, I have to, because I would like to be completely constructive. Okay, so it means that whenever I have a crest, this point, the same point, same point, same point, same point, same point. So I connect all these points together, yes? Good? It should be exactly a line. Okay. This is going to be constructive interference. The second wave is exactly aligned with the first wave. Okay. Good. So I think we are done. Okay. So with the exam prep party, and this is almost 1:46. And is there any question? Okay, we just reviewed the old problem. Okay, 30. It was 40 something problem. Okay, in the practice review, and also there were 2 pages of the graph problems. So and okay, so I think you like the exam prep party, and see you in the next exam prep parties.